Hi, my name is Anastasia, and today I want to talk about database technologies, specifically SQL and NoSQL. Almost every application we use, social media, banking apps, and online stores, relies on databases behind the scenes. In this presentation, I'll give you a short overview of database technologies, explain the difference between SQL and NoSQL, and then show how applications actually store and retrieve data using some real code examples. So why we need databases? Imagine using an app where everything disappears once you refresh the page. That's what happens without a database. Databases give applications memory. They allow data to persist over time even when users log out or servers restart. They also keep the data fast, safe, and organized, especially when many users are accessing the same system at the same time. SQL databases are a relational type of database. This means that the data is stored in structured tables with rows and columns, and these tables can be linked to each other using keys that can be used as a reference. This structure makes SQL very reliable and predictable. It can be great for some of the data that you need to store, like user data, payments, or history of orders. The data that needs to be stable and saved over time. The downside is that the strict structure can make large-scale distribution and scaling more complex, especially for bigger projects. NoSQL databases take a different approach. Instead of fixed tables, data is stored in flexible formats like documents, key-value pairs, or graphs. This flexibility makes NoSQL databases easier to scale and adapt when data changes often. However, because the structure is less strict, consistency can sometimes be weaker compared to SQL. It means that the data becomes consistent over time instead of immediately. So let's sum up what we have so far and what are the main differences between SQL and NoSQL. So SQL focuses on structure, consistency, and precision. It's ideal for business-critical data, like login information or financial transactions. NoSQL focuses on flexibility, scalability, and speed. It's commonly used for things like chat messages, activity feeds, logs, and others. In practice, this isn't about choosing a specific type of database, it's about choosing the right tool for the specific task. Let's look at a real SQL example using PostgreSQL and JavaScript. First, we create a connection pool using the PG library. This is the library that's needed for PostgreSQL. The pool manages database connections for us automatically, which is important for performance in real applications. Then we create a user table. Here you can clearly see SQL structure, columns, times, primary keys, and constraints like unique emails or that specific columns cannot be null. This way, the database enforces the rules for us and keeps the structure clear and strict. Here, we interact with the table. First, we insert a new user using an SQL insert statement with parameters using $. This keeps the query safe and prevents SQL injection, which is important for security. Another example is how we can fetch users' data using a select query. The important thing to notice is how explicit everything is. We define exactly which columns we want and how the data is structured. Of course, any query can be enhanced to get a more specific result, and let's talk about it in the next slide. So, these are some of the most important SQL commands you would use daily. Select reads data. You can set asterisk symbol to select all the columns, as you can see in the example, or you can input the specific name of the column that you want to get data from. Where filter the data. So you can choose to see the entries where a specific condition is met, for example, a specific name of the user. Limit controls how many entries you want to get. This is important not to overload the system if there is too much data in the database. Order by sorts results based on the selected column values in ascending or descending order. Commands like insert, update, and delete allow us to modify data. Once you understand all these commands, this already covers the basics, need data when using SQL. Now let's look at basic NoSQL syntax using MongoDB. First, we connect to the database and get a collection. Notice there is no table creation step because collections are created automatically when data is inserted. Then we insert a document. The data looks like a normal JavaScript object, which feels very natural for a JS developer and should be pretty easy to pick up. Finally, we fetch all users using a simple find call. Here you can also filter the data similar to the way we did it with SQL. Let's see the next slide for more examples. These are common MongoDB operations. Find is actually similar to select in SQL. Filters are written as objects instead of SQL conditions. Sorting and limiting results are done with methods instead of keywords. Update method uses set to declare the changes, and the documents are identified by ID, which is a unique value and is kind of a primary key in MongoDB. Also, you can see the example of insert operation with object as a parameter. Similar syntax is used for delete operation. In the real-world systems, SQL and NoSQL are often used together. For example, a system might use SQL for user data storage because this is an important data that needs to be consistent and at the same time it's not updated too often. On the other hand, NoSQL is used where data structures change rapidly and traditional SQL databases struggle, like chat messages, real-time analytics, gaming, and so on. So this is used for cases where we have loads of data and we need the updates really quickly. The key idea is not choosing sites, but choosing the right tool for each specific task, so choose wisely. And this brings me to the end of my presentation. In conclusion, I invite you to dive deeper into the topic and give it a try at your own pace. I use such sources as w3schools.com and geeks4geeks.org. Also, ibm.com to sum up the difference between SQL and NoSQL. I will leave the links in the description. Feel free to have a look at them. And to sum up, have a good day and keep learning.